Hello there once again. Welcome back to our Exam 3 review series. This time we're doing question 4a, which says use division to show that the given number is a zero of the polynomial and find the other zeros. The number they give us is -2, and then the polynomial they give us is x to the third plus 4x squared plus 2x minus 4. You have the option of using either long division or another approach called synthetic division. Now, long division I've reviewed already. That was in problem 1. In that case, you would just take x plus 2 and then put your polynomial inside the division sign and just do long division the way that we showed you in problem 1. However, synthetic division uses a slightly different approach here. For this, we're going to put the -2 that they gave us in a little box over here on the left, and we're going to list out the coefficients of the polynomial they gave us on the right side. So we start with x third. There's no number, so 1, 4x squared, 2x minus 4. Just list out all the coefficients until you reach the end. Now what we do next is bring down the 1 and then multiply that 1 times the -2 on the side. Well, 1 times -2 is -2. And now just do the math straight down. 4 minus 2 gives 2. Now multiply that 2 times the -2 on the left once again. 2 times -2 gives -4. Then we do the math straight down. 2 minus 4 gives -2. And then -2 times -2 gives +4. And if we do the addition and subtraction here, -4 plus 4 gives 0. If you get 0 at the end, that means -2 is a zero of the polynomial. That's what we expected to get this time. If you don't get 0 here, that means there might have been some sort of math error somewhere in the middle. Well, now we've proven that -2 is a zero of the polynomial they started us with, but now they want us to find the other zeros. Here's how we can do that. We have 3 numbers left over, and it turns out that these 3 numbers correspond to the numbers in the quadratic formula. Quadratic formula goes -b plus or minus root of b squared minus 4ac over 2a. Now, the last term they give us is the constant term, c. The term next to that is b, and the term next to that is a. We could, if we wish, rewrite this as 1x squared plus 2x minus 2. From here, we place all 3 of those numbers in the quadratic formula. So our first number is b, so we'll say -2 plus or minus square root of 2 squared minus 4 times 1 times the c, which was -2, divided by 2a. Well, since our a is 1, that's just 2. Now to continue this, we're going to have to simplify this square root. So we begin with square root of 2 squared minus 4 times 1 times -2. Well, -4 times 1 times -2 gives +8. And then 2 squared, of course, is 4. So we have square root of 4 plus 8, which is square root of 12. However, we can split that square root into square root of 4 and square root of 3. The reason I use square root of 4 is that it is a perfect square, and we can just rewrite that as 2 root 3. So when I rewrite this in simplified form, I would have negative 2 plus or minus 2 square root 3, all divided by 2. We could rewrite this one more time and have negative 2 over 2 plus or minus 2 square root 3 over 2. These 2's cancel out, and these 2's cancel out.